Hi everyone, welcome back to the Code2Conquer series, your step-by-step guide to mastering DSA for placements. This campaign is brought to you by the Google developer groups at VIT-AP. Now, we've completed the first problem of day 17 and now we are moving to the second problem. So let's start. What is the problem statement? We have to reverse a doubly linked list. Now it is similar to the problem one which we solved previously. It is reversing a singly linked list. So this is nothing but the same problem with the doubly linked list. So coming to the description, we'll be given with the head of a doubly linked list and we should be reversing the list entirely and return the head of the new list. So the input will be the same. Will be the head of the doubly linked list as I previously told you. Coming to the test cases, if we are given with a linked list of values 10, 20, 30, 40 and 50, after reversing them, we'll be having 50, 40, 30, 20 and 10. If we are given with a linked list with value 30, we'll be having output as 30 because the reverse of a single element is always itself, right? So if we are having null, there are no elements in our linked list, we'll be having output as null as well. So if the input is 10, 20, 10, 20, so we'll be having our output as 20, 10, 20, 10. This 20 will be over here, this 10 over here, this 20 over here, and this 10 over here. Now let's come to the coding part of reversing a doubly linked list. So we'll be given an input like this. So 3, 4 and 5. So we should reverse it and make 5 as the head. So 5, 4 and 3. So I hope you are getting what I mean. So this is reversing a linked list. So if you're given an example like this 7, 75, 122, 59 and 196. So you should be reversing the linked list entirely. 196 will be the new head. So the expected time complexity is around big O of n and space complexity expected is big O of 1. So the number of nodes in the linked list can be around can be lesser than 10 to the power 6. So yeah, let's come to the coding part. So this is a code and let me explain it properly. So yeah, so imagine this is our previous linked list. The initial linked list given to us. So we'll be given with 3 as the head. So the forward pointer or the next pointer goes with yellow and the previous pointer goes with red. So what does reversing a doubly linked list mean? It means that the previous should become the next and the next should become the previous. So let me explain. So this is our initial linked list, right? So we want our final linked list to look like this. So initially the previous of 3 was pointing to null and then next of 3 was pointing to 4. But now we want to change this. So our previous of 3 should be pointing to 4 and the next of 3 should be pointing to null, right? Similarly for 4, the initially the next was pointing to 5 and previous was pointing to 3. Now we want the previous of 4 to be pointing to 5. We change the values. Initially it was pointing to 3, now it will be pointing to 5. And the next of 4 should be pointing to 3, which was reverse of the initial. So what did you observe? For every node, we just swapped. We swapped the next and the previous pointers. So what does this mean? We have to for every node we have to swap the pointers. The next pointer will point towards the previous node, and the previous pointer will uh, point to the next node. So this is nothing but swapping. So what do you do when we are asked to swap? Suppose there is an integer a of value 10 and there is an integer b of value 20. How can we swap this? We'll do this using 3 instructions, right? 3 steps, right? First we'll make temp equals a, then we'll modify the value of a to b, then we'll modify b's value to temp. So temp will be stored with 10 over here, a will become 20 and b will finally become 10. So finally our a is 20 and b is 10. We'll apply the same logic over here, right? So what will we do? We will assume we will point a pointer called current at the head of the uh, at the head of the given linked list. So this is our head, right? Initially this is our head, so we'll be pointing our current pointer over 3, right? So we'll be doing these steps, these 3 steps to swap the pointers. So how can we do this? It's simple. So let's take temp equals current dot pre. Okay, let me write, I'll explain it later. So currents pre equals currents next. Got it? Currents next equals temp. So can you see the similarity? Temp equals A equals B equals temp. Temp equals currents previous equals currents next, and currents next equals temp. So I guess you saw the similarity. They are very similar to each other. These 3 steps swaps the next pointer and the previous pointer. So if we perform these 3 steps, assuming current is at 3, 3's next will be swapped with the 3's previous. As you can see, they both are swapped, right? They both are swapped. So this is exactly what we want to happen. So for this, we will forget about this if condition for now. I will explain it later. Temp equals currents previous. Currents previous equal to currents next. Currents next equals temp. These 3 steps are responsible for swapping the pointers of the current node, right? So we swapped the pointers for 3. They are swapped. Now we have to go to 4 and do the same again. We have to swap the pointers for 4 as well. So we have to go to currents next. But what did we do? We swapped the currents next with currents previous. Here we are swapping A and B. What are we swapping here? We are swapping currents previous and currents next. So currents previous will be currents next, and currents next will be currents previous. So we cannot go from 3 to 4 using currents next. Currents next will be pointing towards null, as you can see. So we should go to 4 using currents previous. So we will be using current equals currents previous to go to the next node. So after performing this step, our current will be moving from here to here, right? So our current is not over the head anymore, and it's over 4, and we'll swap the next pointer and the previous pointer using these 3 steps again, and we'll go to currents pre, which makes our current go to 5. All right, so I hope you got clarified about these 4 steps. These 3 steps for swapping the pointers, and this step for going to the next node, or the next node initially. I mean, from going to 4 from 3, or for going from 4 to 5. So I hope you got these 4 steps. Next thing, let's come to this if condition. Another important thing, you should run this while loop till the current does not reach null. I mean, we want our pointers to be swapped for 3, then we want our pointers to be swapped for 4, then we want it swapped for 5, right? But when the current reaches null, it's done. We swapped all the pointers required, and we completed our required reversing the doubly linked list. So there's no point of doing anything over when current reaches null. So as soon as the current reaches null, stop the while loop. So now coming to this if condition. Now another important thing is that we should be returning our head after the after reversing the linked list, right? So we should return the head of the linked list after reversing it. So what will be the head? So what can you say? So I will make you see a pattern over here. 3's next initial, this is the initial linked list. 3's next is not equal to null. 4's next is not equal to null, but 5's next equals null. And as you can see here, what should we return our head? What will be our head after reversing the linked list? 5 will be our head. So what can you do to make 5 our head? So you can run this if condition. If currents next equals null, if the next element of the current node is equal to null, then we have to make it our head, because after reversing the linked list, the last element in the given input linked list will be a new head, right, after reversing it. So how can we make sure that the last element is our new head? If the next node of the current node equals null, that means in the initial given input, if we are at the last node, make it the new head, and we will return the new head. Alright, so after this step, 5 will become our new head, and we swapped all the pointers. So as you can see, three's pointers are swapped, 4's pointers are swapped, similarly 5's pointers, and 5 will be made our head, because initially 5 was the last element, and now 5 will be made the head, so we'll be returning 5. So this is our reverse linked list, and yeah, so 5 will be our head, next we'll go to 4, next we'll go to 3. So similarly we reverse the doubly linked list as well by swapping all the pointers. So to summarize this, it's nothing but swapping. We should be swapping the pointers, currents previous and currents next, right? So I hope you got this. Just make sure that you run this if condition as well to change the head to the last node of the given input. And coming to the space complexity and time complexity. Time complexity. You can see that we are only running this while loop only for n times. I mean, if there are n nodes in a linked list, for this example, it will be time complexity of 3. To be precise, the time complexity will be big O of n if there are n nodes in a doubly linked list. And coming to the space complexity, it will be big O of 1, because we are not using any extra space. We are only using the pointers, which will be taking constant space complexity. So time complexity will be big O of 1, and space complexity will be time complexity will be big O of n, and space will be big O of 1. Now, this is the best approach for doing this doubly linked list. Now, similar to the problem 1, we can also do this using stack. So we'll be keeping these values in the stack 3, 4, and 5. So stack will be having values like first 3 will be there in the stack, 4 will be there in the stack, 5 will be there in the stack. Then finally we'll remove these elements. 5 will be removed, and the first node of the linked list will be updated, 4 will be removed, and 3 will be removed. So there is no need of modifying the head as well in this case. So we can also do doubly linked list using the stack method, as explained in the problem 1 of day 17, singly linked list, reversing a singly linked list. So yeah, we can do that using a stack, and we can do that using this swapping method as well. So I hope you got clarity about this. So this is all for this problem. Let's meet in the third problem of today. So thank you.